Sine and cosine graphs and their transformations. So today we will be talking about sinusoidal equations and their transformations. This is one of them. Cosine times x equals y. Here's the next one. This is the parent sine function. So this one intersects the y-intercept here at the origin, while this one intercepts at 0, 1. So that's very important in deciphering between the two. There are many different ways to transform the graphs, so we're going to look at a few of those ways.
Right. So, in one of the transformations, we will be discussing the a value. The a value controls the amplitude of the graph, and the amplitude is the distance between the midline and the maximum, or between the midline and a minimum. Or if you take the distance between a maximum and a minimum and divide it by 2, that will also be your amplitude. It goes right here in the equation, and it's represented by A. Alright, we're going to skip B because B gets a little more complicated and go to C. The C value changes the midline in the equation, which would be over here. So let's say that here the midline is at 3, so C equals 3, and it would look like 3 in the equation. Or if it's at -2, then it would be cosine of x minus 2.
Okay, so now we're going to talk about D. Changing the D value, which lies here in the equation, shifts the graph left and right. So you will hear people refer to this as the phase shift if you're ever studying it. So here the x-axis is expressed in radians. So instead of 1, 2, 3, 4, it's pi over 2, pi, and so on. So the dotted graph is the parent cosine graph. Notice how it intersects right here. And the red line is the phase shift. So this cosine graph has been shifted pi over 2 to the right. So if you put this into the equation, you would put it pi over 2, x minus pi over 2 into the equation, and it would shift it to the right. Okay, so now we're going to talk about B. So first of all, before we can determine B, we have to find P, which is not included in the equation. P is the distance between two maximums, right here, or two minimums, which would be right here. So once you have that value, use this equation right here to find B. So for example, if your P is pi, and you have B equals 2 pi over pi, and solve that, and you get B equals 2. So then you have your B value.
Okay, so now that we figured out how to find B, we can see that B fits into the equation right here. And so all of these variables also apply to the sine equation. So it would look more like this if you did a sine equation. Right. So now that we know what all those variables are, we're going to try finding the equation using a graph. So since our maximum is at 3 and our minimum is at 2, we know that in between that is +1. So our midline is right here, and C equals 1. So we can tell right away that the graph intersects the y-axis at its midline, so we know that it is a sine function. However, we could say it were a cosine function, and it has a phase shift of -pi, but since we're saying it's a sine equation, it intersects here, then there is no phase shift. So now we can determine the distance between the midline and the maximum, which would be right here. And that distance is 2 units, so our amplitude is 2. And all that's left is the B, and that's when so now we're going to determine the P value here. And the distance between these two maximums and these two minimums, since it goes from -3 pi to +pi, that's 4 pi, so the period is 4 pi. Then we'll use this equation, B equals 2 pi over 4 pi, and if you simplify that, it comes to 1/2, so our B is equal to 1/2. Now when you put that all together, you'll get y equals 2 sine of 1/2 x plus 1.
Thank you for watching.